At Curragh Global Resources, we are committed to elevating our safety capabilities at our mine sites. The reality is that any system is comprised of three key elements: equipment, process and people. Improving our safety capabilities is therefore reliant on how effectively we can balance these three elements. With this goal in mind, we've undertaken a project to develop a functionally safe dragline, specifically focusing on trigger events impacting the control of the slew mechanism. We call this the Proximity Awareness System, or PAS. This innovative and cutting-edge application of technology has the potential to transform the mining industry. The Proximity Awareness System draws on learnings from different industries regarding the use and application of equipment and the associated technologies, as well as the experience gained by people using this equipment and those different technologies. By assessing the overall process, we can apply these learnings to enable our dragline system to achieve a functionally safe rating. In this presentation, we will explain how the system works, discuss the challenges we face during its development, and share its impact on our daily operations. My name is Blair Whitney. I'm Curragh's Site Senior Executive and General Manager, and this is our journey.
Curragh Global Resources is a leading international producer of high-quality metallurgical coal, an essential element in steel production. Our coals, transformed in the steelmaking process, support the manufacture of everyday steel-based products, including renewable energy infrastructure that enrich lives around the world. We are one of the largest metallurgical coal producers globally, serving customers on 5 continents from our operations in Australia and the United States. Our company has grown from humble beginnings, producing less than 0.5 million tonnes from our Greenbrier acquisition in 2013, to producing more than 16 million tonnes in 2022, and with plans to organically grow to 20.5 million tonnes by 2025. Curragh Global Resources currently operates 4 draglines in its fleet, all of which are located at our Curragh mine in Queensland. Curragh is an open-cut mining operation, where coal extraction involves removing the overburden from the top down. Typically, open-cut mines are excavated on benches, which represent vertical levels of the pit. The height of the benches is determined by the machinery used to remove the overburden or product. It is in this context that our draglines operate. When considering how draglines operate, they can be seen as simple machines. However, engineering challenges arise due to the scale of these machines, often pushing the boundaries of material science. Our largest machine, the Marianne 8750, has buckets that can typically lift 220 tonnes per cycle. It can lift material from 65 metres below ground level and throw it 60 metres above ground. The boom is 100 metres long, weighing 6,800 tonnes. We achieve a typical cycle rate, dig, lift, swing to spoil, dump, swing to dig face, of 80 seconds, while running off an extension cable that delivers up to 20 megawatts of power from the grid. At our core, ensuring the safety of personnel and equipment around heavy machinery in the workplace is of utmost importance for a sustainable future. Our people define who we are. Traditional operational methodologies or procedures may not provide operators with sufficient awareness of nearby personnel or equipment, creating potential risks. Currently, there is no solution in the market for a dragline that can be considered functionally safe according to recognised standards. In everyday terms, this means that everything has single points of failure, or is strictly controlled administratively, which is the lowest control measure when considering the hierarchy of controls. The Proximity Awareness System, or PAS, aims to be an engineering control that addresses these challenges. It automatically notifies operators and takes appropriate action when personnel or equipment enter the defined operational zone around the machines, typically within the boom point. This system ensures a higher level of safety and minimises the risk of accidents in the mining environment. The PAS is a dragline-centric solution, which means that all components are contained within the machine and do not require external connectivity or computation. Our approach involved implementing 3 discrete systems with overlapping sensing areas. which were integrated into a single user interface for ease of use. Each system had its own design and deployment criteria and requirements, but they were all developed in parallel to ensure the shortest possible timeframe for completion. We primarily used off-the-shelf parts readily available in Australia, ensuring easy maintenance and cost-effectiveness. This system is designed for scalability, making it easy to implement across our draglines. We embarked on our journey in early 2022 through an ideation phase with multiple internal and external parties involved. The conversation was premised around the current state of machine learning and methods of achieving a functionally safe outcome. Given our time constraints, the only viable approach was to pursue parallel paths. These paths included camera development, LiDAR development, radar development, functional safety development, software integration, HMI and infrastructure. In total, 8 distinct interwoven paths were pursued, with the main focus on sensor validation and deployment. Our challenges, both obvious and hidden, included the scale of a dragline, as we had to design sensing zones that covered a large area around the machine. Additionally, we faced complexities related to edge computation, as we needed to ensure that the system had both the availability and raw computation power to process the large amount of data produced by the sensors and consumed by the algorithms. Another challenge was the state of machine learning, as we aimed to create a system that was easy to deploy and maintain. Given that the system would be operating in an industrial environment, it was crucial to ensure that the sensors we used were rated for such conditions. To achieve the system outcome that is compliant with the relevant safety standards, such as AS 4024, these challenges were carefully considered and addressed throughout the project to ensure the successful implementation. Lastly, a significant challenge we faced revolved around user adoption while introducing a new technology during the rollout.
Until recently, automation systems in industry have largely been limited to fixed plant deterministic systems. These systems respond in a predetermined manner to known and clearly defined states, modes of failure, and external conditions. Increasingly, with the advances in technology and the shift in mining towards automated systems and processes, has driven the adoption and integration of non-deterministic systems. These are systems that perform complex functions utilizing tools such as pervasive sensing, dynamic models, and machine learning. Existing standards facilitate the assessment and an assignment of performance levels and safety integrity levels to the safety-related parts of the control system in deterministic systems. As they are simple and explicitly defined by necessity, it is a far simpler process to apply these methodologies. Systems that are non-deterministic, such as those that involve perception, for example vision or GPS systems that perform collision avoidance functions or route planning, make decisions based on models and probability. Throughout this process, Curragh has undertaken a risk-based evaluation approach that combines both traditional and application-specific risk management techniques, a vigorous research and development process, a best practice-driven testing and validation framework, and collaborative engagement of relevant stakeholders from OEMs and industry to develop and implement a proximity awareness system that covers the hierarchy of control and results in a functionally safe and compliant outcome. Our solution leverages 3 distinct sensing technologies: optical, LiDAR, and radar. The proximity awareness system uses 25 radars that cover the 0 to 4 metre range, 5 LiDARs that cover 3 metres to 25, and 5 optical devices that cover the area from 5 to 50 metres. The sensors are deployed such that they form 5 distinct zones that cover the rear and the sides of the dragline operating footprint. The non-deterministic outer 2 zones utilise 2 separate AI models that monitor the optical and LiDAR sensor data to detect and classify the presence of personnel and equipment. This enables the machine to be brought to a controlled safe state following detection. The outer system is designed to alert the operators to personnel breaches, reduce proportionally to the breach distance the speed at which the machine is moving, and brings the machine to a safe state, while the inner deterministic system locks out the swing function and requires a physical reset. Due to the arrangement of the sensors and the overlapping sensing fields, blind spots are eliminated, ensuring complete coverage of the dragline side and rear operating areas. complementing the proximity detection functions, zone access control, and pre and post reset functions for boarding and disembarking ensure that the location of personnel is monitored and controlled by the operator at all times. This comprehensive coverage is a crucial aspect of the system and ensures that every angle is covered, allowing operators to work safely and efficiently.
The basic operational principles can be simply demonstrated with a boarding procedure. The scene is set with the park-up zone here. The boarding cone is here. The machine must be stopped prior to moving closer, and the drag line. Here is John, whom we will be shadowing, and this is Ben in the chair operating the drag line. As soon as John reaches the camera's active zones, 50 metres, it is flagged to the operator's cab on the HMI, and the system actively tracks him until the next layer has an event, which is the LiDAR, 25 metres. Here's what the LiDAR generates, and this point cloud shows the AI recognising that John is in fact a person. The systems cross-check and validate that a control action is required. The control system starts applying a clamp to the slew reference to reduce the machine's top speed. As John steadily approaches the machine, the clamp is adjusted proportionally until he reaches the boarding cone, where the machine stops and Ben confirms that John is okay to board. The last action occurs when John breaches the radars, 5 metres, where all slew mechanisms are locked until a reset is completed. As John gets onto the machine, he verifies that the zone breach is clear and resets the system. The drag line then goes back to work. The system works in reverse for personnel disembarking the drag line, where we have the machine in a safe state, stopped, prior to leaving the machine. The radar is immediately triggered and locks the slew out. The operator on board is required to do a reset out of the local reset station prior to resuming work.
I'm John, I'm a dragline operator and I've been at Curragh for 17 years.
I'm Ben, I'm also a dragline operator at Curragh and I've been here for 18 years.
I think first impression was it's going to be pretty complex to work with, but it should take a lot of the guesswork out of our hands and protect people on the ground that you can't see.
Yeah, with the boarding, with the LiDAR system, takes the human error out of it. If someone walks in, the LiDAR picks them up, starts slowing you down, gives you warnings. It takes that away from just the operator. There's a hard control in there.
Currently we do a lot of work on the ground around the machine, and the machine has very limited visibility. It's hard to keep track of people while they're outside working. With the radar picking up the person entering the last 5 metres, it should eliminate the risk of anyone being injured by the machine at all.
We recognise that we don't have all the answers, and that's why we believe in the power of partnerships. By collaborating with the right individuals and fostering win-win relationships, we can unlock new possibilities and achieve greater success. This principle applies not only to our dedicated team members, whom we greatly value and appreciate, but also to the industry experts who bring their invaluable insights and support. At Curragh Global Resources, we have forged strong partnerships for success with a range of esteemed Australian and international businesses. These partnerships have been instrumental in driving our progress and helping us reach new heights. We partnered with multiple Australian and international businesses, including for our software and HMI machine learning interfaces via BigMate, our engineering, manufacturing and compliance sign-off. PFI helped out in that space. Our computer hardware and edge servers via Lenovo, our LiDAR radar hardware and our manufacturer and importer via SICK, and the camera hardware supply with Motorola. All our installs were done by our electrical contractor, SJE Services. We have developed and deployed the performance level rated system on a dragline in Australia. This system incorporates 2 separate AI models. The on-site team has done an exceptional job starting from a casual discussion and transforming it into a significant achievement. In the coal mining industry, success is defined by people in the business and also the partnerships that we form. By sharing a common goal and working with like-minded individuals who are willing to challenge traditional practices and embrace innovative and collaborative approaches, we strive to constantly improve and make each day better than the last. At Curragh Global Resources, we firmly believe that our safety standards can be enhanced, and we remain resolute in driving continuous improvement every day. I'm immensely proud of the dedicated team involved who have enabled me to share our story and convey our learnings about the dragline proximity awareness system to the wider industry. We extend an open invitation to visit our site and witness the system in action firsthand. If you're eager to learn more, please don't hesitate to reach out. Let's connect and have a conversation. I'm Blair Whitney, and we are Curragh Global Resources.